Hope the day one would have been useful to you. All right. So from the day one, we started with what is about image processing, and then what are the functionalities. We have dealt about 4 packages today. So basically, we need to know about the package and its usage, and then only we'll be able to start working with that. Right? We started with NumPy, SkyPy, SkyKit image, and Pill. Okay, today we are going to start with the topic called as OpenCV. Okay, OpenCV. So before we go into it, yesterday, do you remember I was asking you what are the different ideas that you could have that you can do using analytics image on healthcare domain? Anybody would like to share, please? Do you remember? What did we discuss yesterday? You're there with me? Can you respond, please? Or you can put it onto the chat also. That is okay. Hello? Yesterday's session, we were saying about it. Okay, so what are whether the participants should be able to put onto the screen? Okay. RMSC BBC 2020. So today we will start off with the data session. Is my screen seen to all? Can I get some response, please? Is my audio clear?
Yes, ma'am.
Okay, okay.
Yes, ma'am. Screen is visible.
Okay, then we'll start off with the session. I was waiting for the responses. Okay, yesterday we started with the SkyKit image, the NumPy, the SkyPy, and Pill. Okay, today we'll be seeing about OpenCV. There are different functionalities each packages could do, but during this workshop, for one particular application for functionalities, we are taken for each package. For SkyKit image, we started working with image. Do you remember we worked with image filters, different types of sober, Laplacian, and median filter? Using NumPy, what did we work on with? We worked on with how to mask an image, okay? Using this image and also with the cat, do you remember having the green color we mask? All right. And then using SkyPy, we work with blurring an image. You've seen as a little animal, how we used using the sigma value, blurring and very blurred image. And then using Pill, we work with how to enhance an image, okay, the contrast and the other details. Okay, today moving into OpenCV. Okay, OpenCV, it stands for Open Source Computer Vision Library. Okay, it is one of the predominant packages used in image processing. It's not only in healthcare, in all domains. Okay, okay. OpenCV, it stands for Open Source Computer Vision Library. Okay, open source computer vision library. It's most widely used in the computer visions when you take it. Okay, so it's a Python API for OpenCV. It's not only fast. You would have know. I don't know whether you know. In Python, you can work on C, C++, and Java. Also, it supports the different languages. Okay, it's not only fast since its background code consists of written with C and C++. It's easy to code, okay? And it's a greater choice for all programmers, those who work on that, okay? Computer vision is a field of deep learning, okay? To identify machines to see, process images like humans. You know, when you take into machine learning and deep learning, deep learning output is even more better than machine learning. Okay, here once you do the feature selection, then we move on to the classification model. But in deep learning, it is a coherent. It goes simultaneously the feature extraction and the classification. That is why the accuracies of when you develop algorithms using deep learning methodology, the accuracy is more in comparison with the machine learning. Okay, just this project, like OpenCV just started out as a research project at Intel, for most of the computer processes, we use Intel processor, all right? So it's currently the largest provision library, and currently they have more than 2,500 algorithms. Let me show you the website. Somebody's mic is on. Any doubts, please? Okay. So this is the website for Opencv. Okay, it's a huge library with more than 2,000. There are a lot of competitions available, right? It's started with Intel. Okay, it has been started with Intel. You can go into the libraries. So the latest library, the documents. Okay. So in which we are going to use for image processing. Okay, Opencv. For Python, you have got a tutorials. Okay, how to detect an object. Most of it we'll be seeing today. Okay, so this is the documentation of open source computer vision library. All right. So what are the functionalities? There are many functionalities that Opencv total it's 2,500. We'll not be able to do all the 2,500, but let's see what are the functionalities that we'll be able to do it. Okay, first is how to read and write and display your images using Opencv. We started with SkyKit image, then we moved on to NumPy, then we moved on to SkyPy, then we moved on to Pill, which is called Pillar Python Image Library. Today we are going to start with the Opencv and how to change the color spaces. Okay, if you have a color, then we convert it to grayscale before we start working on with the healthcare analytics. Then how to resize images. Okay, the size of images, they're different size. You can resize image. You'll be rotating images. Okay, you remember yesterday I said when nowadays we started working with mask and without mask. All right. So then we need to have a lot of training data with us. Okay. When the image is on this, it's proper or is it rotated, whatever it is. So we'll be using different rotations and moving up the images, and then we get a lot of training data to train an algorithm to figure out is this a person with mask and without mask. Okay, for the image rotation, image translation. Then we move on to thresholding of an image. What are the different thresholding methods? And then we go into edge detection. How do you detect an edge in an image? Okay, then how will we be able to recognize a face? There are different objects available to detect face. There is a different XML file to detect your eyes, your nose, okay? And if there is time, I'll just show you a demo of image segmentation using RCML. Okay, now let's start. Okay, how do you read and write and display image using Opencv? Machine sees everything using numbers. Do you remember that we saw yesterday the image that we have taken? You see it has a picture, but when we type it, what type of data type was it inside? It was a what array? Do you remember the type of the array of the image? Do you remember this? What was the type of the image? We see it as an image, but what is the data type of the image? It is a NumPy array. I don't know. I'm not able to. Any other? No, when you work even with deep learning, the time is not, it's not more time is not required. It's even more faster, Supratama. It's even more faster. All right. Okay. So it is a type of NumPy array. It's a type of NumPy array. Okay. So I said, right, machine processes all the informations, including images and text. So it is converted into NumPy array. Do you remember doing masking? We were making it into 0 into 255. So when you see onto this image, okay, when it is 0, it is black. You just zoom into the third row, the last two columns. When the pixel value is 0, it is black. And when the pixel value is white, the value is 255. That is what yesterday we did. Some of you were asking why the number was changed. So we converted all the black stages we masked into white using NumPy array. All right. This is an image. Okay. The pixels of an image and it is converted into NumPy array. This is what we see into our NumPy array. Every number that represents the pixel intensity at a particular location. So this is a very good location to figure it out. Okay, when it is 0, it is black. When it is white, it is 255. Okay, so this is how the intensity is taken. Okay, color images have multiple values for a single pixel. If it's black and white, it's okay. So these values are represented in Opencv using RGB channel. Yesterday also we saw about RGB, which stands for red, green, and blue. You remember when we started working with that the Cheshire data with the face of a cat. Then I gave values only to the green, and then you could see the green color RGB. The first value is red channel, the next comma is the green, after the comma is the blue channel. Okay, so reading is very essential. So we'll see how are we going to do it. Okay, by default, the image reads as blue, green, red format. Okay, but we can read it in different formats. I'll show it about to you now. Okay, how do you read an image using CV, computer's vision? Is that CV? This is the functionality that we'll be using. All right, CV2.imread_color. Default flag for loading a color image. Then if I want to take a color image, but I want to load it at a grayscale, then I'll do just CV2.imread_grayscale. Okay. Then CV2 unchanged. So whatever it is, the same format will be loaded. Okay. So I'm not getting any response. Let me ask one question to all the participants. How are you today? You can give your answers onto the chat. Very simple question, nothing from yesterday's class. How are you today? Hello, you're able to hear me? Okay. Here we go. Okay. So now you can open your Colab. Open Colab. And first I want you all to mount your Google Drive. Before which, go to your Google Drive. Do you find any images that you have? You can search. Otherwise, upload some image into your drive. So I have some pictures. I could click and type call an image. It will show you different images. Okay. I have taken this image. Just right. These are different data sets I've loaded it on. So for me, it shows lots of data. First step, you are load into a data. Load a picture file onto a Google Drive. Then come here and then type from google.colab, import, we're importing your drive. So after you have loaded it, you will get a drive kind. Click on the drive, click on my drive. So my drive will have a lot of data. Okay, and I wanted to use this picture. So whatever figure that you've taken, you can click it on and then select copy path. When you type in this coding, here you need to paste the path that you've copied. All right. First, mount your drive, then copy the path, then you can see your drive content on your left. Load the image. So this is the package for Opencv import CV2. Using this function, you remember I'm reading it. And it is blue, green, red channel is converted to red, blue, green. And I'm showing the image one. But this is the original image. This is the original image. Can you see where it is blue? It has become red. Okay. So first mount, then take your path, paste it, and then using this, I'm converting my image into blue, green, red into red, green, blue, because it is the default, it is taking as blue, green, and red, and I want to convert into red, blue, and green. That is what I'm having image one as I'm reading the basic image. And then here I'm converting into using CV2 color. When I plot the image one, it's showing a different image. And then read is to save the image back into your drive. This is where it has been saved. Test write underscore one. All right, what name I've given, it will be again onto your drive. But I'm just showing this is the original image. This is the original image. Can you try these two? But in the path, you should give the path that you need. It does not have any requirements from any time. When you close a Google Colab and again you open, you need to execute just the files from the first. It's always active. Running programs in Colab is always active. There is no time duration or limitations. Once you have done these two, just type done onto your chat. Or became very silent today. Why so? Kindly try it. Jesus. And then if you've got it, or if you've got any errors or any doubts, put onto the chat. So after the end of the session, we have got a small quiz regarding yesterday's session and today's session. It's a live quiz. Let's see who wins it. All right. Kindly do not give the same link. First mount your drive and then select any of the picture that is there in your drive. All right. And then use that CMC, copy the path. Say, for example, if I'm going to, where's this? Yeah. If I want, just click it on, you'll see a 3 dots. Click that and then select copy path and come here and you can paste the path. Okay. And it's a CV, it's the image one. Then I'm converting the blue, green, red to red, blue, green. I'm first showing the image one. And then this is how you read and write it again back into your drive. And this is the original image. So I've converted the path to the original image. Yes, ma'am. So whenever you close it and again start, it will reconnect. And again, from the first, you can run the needed cells that you want to execute for today. All right. I'm getting response only from Suprata, ma'am. What about others? The many participants here. Are you all trying or you're getting any doubts? Please do share. Are you there? Thank you, Nityananda ma'am. You got it. What about others? See, it's a workshop. Please do ask. Some of you may be new to collab. So maybe some of you would be experienced or whatever it is. Kindly share your doubts. Yes, please. Have you tried? Only one response. You can also unmute and answer, no problem. Usha ma'am, you got it? Thank you, Usha ma'am. What about others? Many people, Ashkar, Sudarshan, Augustin, Arul, Angerkani ma'am, Anjit Raja, Deepak, Divya, Felicia ma'am. Yesterday I was able to get responses. Trying it, Joe, Reena ma'am, Frank, Moses, Karthik, Malayarasan, yes, Nitya ma'am. They've given the answer. Sadhana Kannan, Priya ma'am. Saran, Vinayak, Roshan, Bharani Kumar, Rahul. So many of you are there, Sivagami ma'am. Suprata ma'am, you got it? Once you give me a response, I'll be able to move faster to the next. Yes, can I move? The next. Have you got it or are you finding any difficulty also? Please do share. Participants, you can also unmute and answer, I suppose. Are you trying it out? Okay. Let me move to the next. So first, yes. Any doubts? Okay. We started working with how to take the data using Opencv. First step, we mounted our Google Drive. We had an image into a Google Drive, all right. And then we loaded the image from the Google Drive into the Colab. Then we have done the color changes from BGR to RGB. Okay, and then we have stored it right back. Okay, reading, and whenever you get output in your image analytics used for healthcare or any sectors that you do, you need to store it back. That is what we have completed. The next step application that we are going to see is called resizing an image. Okay, say for example, when you are to model it, it should be all of the same size. So machine learning model works with like a fixed size input. So the same idea applies to your computer vision also. If you see, what do I say? If you see MRI size is big or X-ray is a different size, but we need to make it of a fixed size so you can work with all types of images. All right, the same idea applies. So the image we use for training a model should be of the same size. Whatever the data, then you're going to train. Okay, whatever you're going to train should be of the same size. Otherwise, you may get problems. So now, if you're creating our own data set by scrapping images from various sources, you can also scrap images from web scrapping. Okay, so then that comes into it. Okay, so how do you do a resizing? You can scale up an image or you can scale down an image using Opencv. So you have more models to train. If training set data is more, then your algorithm accuracy is more. All right. So, what are the different interpolation and downsampling methods available? You know, it's inter nearest, okay, which is nearest neighbor interpolation, interlinear, which is bilinear interpolation, inter area, which is resampling using pixel area relation. Okay, and the next is intercubic, the 4x4 or okay, 4x4 pixel neighborhood. Okay, and the next is interlac source. Okay, so these are the different population methods available. Okay, let's try. And this first, we have tried, we have taken an image, but it is of BGR format. So I convert it into an RGB. Actually, the original image looks like this. All right. But when I loaded into Opencv and then I changed the color format. And if you want to change from RGB, see, from a listen, from BGR, I converted into RGB. That was in your image file. Using the image file, I'm going to convert my RGB to my grayscale. So this is my output of my grayscale image, of the same image, okay? Grayscale image, okay? And next is converting images into HSV format also. Before that, we'll come into the thresholding. Let's try grayscale first. Try grayscale and HSV. Hue saturation value. Okay, HSV stands for hue saturation. It's changing into the color spaces. BGR to HSV. Let's try converting to grayscale and HSV. Try these two. Same image where I've converted my BGR into RGB and then I converted into grayscale. And next converting the color spaces into HSV. Jesus. Okay. Once you have done it, kindly let me know.
Ma'am, good morning, ma'am.
Yes, ma'am.
Ma'am, I'm a little bit late to the webinar.
Okay.
Ma'am, can you help me how you open the CV, ma'am? Imported Opencv, ma'am. Declare the CV.
Yeah. First, you need to,
Yeah, ma'am.
it's not for Opencv. First, you need to mount the Google Colab. Okay. From your drive, we have a Google Drive. From the drive, I mounted this using the first two lines. And then for Opencv, I've imported for plotting, PyPlot as done yesterday, and import CV2. And after I mounted it onto my Google Drive onto Colab, you will get drive like this. You can click onto the drive. You can select one of the images from your Google Drive. So when I have used this ISDE webinar. So I just clicked it on, you will get copy path. You can copy the path and then come back here. And after you mounted it, you will be getting the data, copy the path, and then import your Matplotlib, PyPlot, CV2. And here you have to paste the path. Just paste. Okay. So after you copied the path, you will be pasting it. Okay. And then because it is of BGR, I'm converting into RGB. In image one, I have got my BGR format. This is my BGR format. Where blue is converted into green, blue is converted into red. But my original image was, this is my original image. So in image one, whatever I'm reading it is there. And in image, I've got using CBT color. I'm converting my blue, green, red to red, blue, green. Sorry, red, green, blue. And then I'm showing the image and I'm writing it again back into my Google Drive. I'm
Okay.
showing this image. And now converting into the grayscale and HSV. You've copied this?
Yes, ma'am. Thank you, ma'am. Thank you.
Okay. Have you all completed gray and HSV? Participants, kindly respond, please. Yeah, thank you, Usha ma'am. Others? So next is resizing. Okay, when you come after grayscale and HSV, we started with opening CV2, loading an image, resizing. Now we are into resizing. In resizing, you remember I told you different types of interpolation. I'm taking internearest. You can try interlinear, interradial, intercubic, and interlangsos. Okay, so resizing an image. I'm taking the same image in the variable image. I'm making the image as half. Okay, CV. This is the formula to make the image as half of the image. Okay, and making it bigger, the bigger image. Okay, of what size you need, and if I want to stress using resize. So these are the different functionalities for resize. Interpolation are different methods. I've used the first method, cv2.internearest. So I'm giving my titles to display my image. Original, half, bigger, and interpolation. So original is my same image here, half of the size, the bigger, the stretch, and the count is 4. So I'm making a for loop using Python for I in range of count of 4 will be 4. For first it plots here, and then it increases I plus 1. It shows the title and I am show, and the entire plot is being shown. All right. Yes, I will show it. We are going to work on with that. Once we completed the basics, then we'll be taking an image of cancer image using MRI. See, these are the basic things that you need to work on. Once you're strong in your basics, any data set that you're given, you'll be able to work on with that. You can take any data set that you need to use. Are you working with image resizing? Once done, kindly put onto the chat, it's done. Even inside, I've used this image. You can use any kind of healthcare data sets. We all completed this. Any doubts, kindly ask, please, on the chat. And I've sent an image y1.jpg to everyone on the chat. Kindly download it and upload it on your Google Drive. This is an image of a tumor. Okay, this is an image of a brain MRI with the tumor. We'll see how are you going to take the edges out of it. Once we completed resize and rotation, have you all completed resize? So once you've completed, can you download the image that I've shared it to you or the chat and then load it onto your Google Drive.
Ma'am, where it is shared, ma'am? It's in the chat window.
Yes, ma'am. It's on with the chat. It's on the chat.
Okay.
I've shared it with everyone. y1.jpg. You got it, ma'am?
No, ma'am. Maybe like due to network issue. Can you send it, ma'am? Sorry.
I can send it again. No problem. Again, send it onto the chat. Others, any one of you have got it? Can you please tell me? On the chat.
No, ma'am, actually. Maybe.
Who's saying no? And see, go on to your chat. You will be seeing the file. I am able to download it.
Okay.
May I know who's anybody has downloaded? Please, one of you go to the chat, check onto the file. Felicia, ma'am, you got it? Felicia, ma'am, have you got it? Jose, ma'am. Anybody? Nitya, ma'am, have you got it? Or shall I share it into your WhatsApp? I don't know. In WhatsApp group, I may not have access. Usha, ma'am, you are able to download? Kindly respond, please. One of you can
Yes,
unmute.
ma'am. I downloaded.
Oh, you have
I got
downloaded.
it. Yes, I got it.
Thank you. Others also kindly quickly download and load it onto your Google Drive.
Ma'am, it is not viewed, ma'am, in the chat window.
Who's saying, ma'am? Who's speaking?
Abhirami.
Abhirami.
It is not viewed, ma'am, actually.
Again, I'll share.
For
Maybe-
me, it is not. I'm not able to view it, ma'am. Can you please share it with me?
Again, I'll share. No problem. I'll share it again. Go look onto the chat. Now, are you getting it? Even Usha ma'am has again shared, and I've also shared. You can see onto the chat. Just click it on. You can download it. Y1. It's there, right? Just click on the Y1.
Ma'am, yes, ma'am. In the chat window, we are finding only the message sent by the participants, like no, yes, only the response they have given, not the link, ma'am. I don't know. Maybe
It's not a link. It's an image that I've shared.
yes, ma'am. Whatever it may be, we didn't. Sorry, ma'am. I didn't find. I'm sorry. Only the
Okay.
responses are viewed, ma'am. Like no, yes, of the.
Okay.
I'm sorry, ma'am. Maybe.
No problem. No problem. Wait. I have a link and I have the image. I'll make it shareable.
And so one more ma'am is also saying there she's not viewing.
Some of them have got it.
Okay.
Now from my Google Drive, I'm
Yes.
sharing the link.
Okay.
Now you try whether you're able to
Yeah,
download.
now, yeah, ma'am, now the link has come.
Okay.
We'll
Now
try.
try. Now try to
Yes, ma'am.
download.
Yes, ma'am. Thank you, ma'am.
Let me know whether you're able to download. Try this link again. Try this link again.
Yes, ma'am. Yes, ma'am. We got
Now
it.
you're
I
able to
got
download.
it. Yeah, yeah, I got it, ma'am.
Thank you. So how many of you have completed resize? And next is rotation. You have resize, rotation, thresholding. After that, we'll be moving on to the canny edge. Okay, and then for rotation, to get more samples for training, right? We need to, so then only to be able to clearly figure out whether the images of any size or rotation or if any kind of translation, you'll be figure it out using your algorithm. So rotation is one of the easiest method to get data to be augmented, your data augmented technique. Okay. And next is image translation. You shift the variance. Okay, you shift your variance. Okay, that is, there are different thresholding. A simple thresholding, you'll be seeing about it. Okay, now we'll try working with your image rotation and image thresholding. This is for image rotation. I hope resize you should have done it. Okay. It's for resizing the image. Now rotating. Okay. Can you see how it has been rotated? Shifting it. And the next concept is thresholding. Once we complete these two, we'll move on to our canny edge. Okay, there are different types of thresholding: binary, binary inverted, threshold truncated, threshold to 0, threshold to truncated inverted. So these are the basic things in CV. We have completed resizing. Now we'll work on with rotation of the image. All the rows but columns I'm by 2, and then I'm rotating it to 90°. Using wrap affine function, I'm displaying the columns and the rows that I've taken. Try this. Once you have tried, get me answer as done. I have used this picture. You can use your pictures of your healthcare or whatever you have. Data augmentation is more important when you start developing as research scholars or doing research, okay, to get more samples of your data. The more data samples that you have, the more accurate will be your algorithm. So the concepts that we have learned today is to read, resize, and display an image. Okay, read the image, display the image, write the image. Then we work with the converting the scales to, excuse me, to grayscale to HSU. Then we work with rotating and resizing of different kinds. We'll come for thresholding now, ma'am. Suprata, ma'am. Now we are into rotation. Next we'll come into thresholding. Have you completed? Whether you have completed this one? Thank you, ma'am. So this is also same thing, but here I'm changing my rows and columns. Here it is rotated. Here I'm not rotating but shifting it. Okay, but shifting it. Using these values, I'm shifting it. Okay. So you are asking about the thresholding. Okay, we have seen about image rotation, image translation. Okay, transferring the map to every object. Okay, rotation we have done. Translation, I just showed you how are we doing it. Shifting the variance. Can you see we are shifting the variance here? How are we shifting it? Using wrap affine, I'm shifting. So here also when you shift an image, there also you get a lot of data to be augmented. The next concept that we are going to see is called image thresholding. So image thresholding is important for image segmentation. You need to segment an image. Okay, it compares the pixel values and updates accordingly. Okay, here multiple variations of thresholding is supported in CV. Okay, multiple variations of thresholdings are supported in CV. If the image is great, you have a threshold value. If the image is greater than the threshold, okay, if the image is greater than the threshold, then you make it 1. Otherwise, you make it 0. Okay, but remember carefully, threshold can be applied only for grayscale images. Okay, thresholding can be applied only for grayscale images. Okay, so this is about image rotation. This is image translation. Okay, same wrap affine function, but I'm doing my it's translation of my image. Now I'm converting the image into my grayscale. Okay, this is my grayscale image. All right. And one, see, to do a thresholding, it should be done for grayscaling. Thresholding is very important concept for image segmentation. Now you see here, I'm loading the same image. What are the different thresholds? Okay, threshold binary inverted, threshold truncated, threshold to 0, threshold to inverted. Can you see this is the original image? Okay, this is the original image. Okay, the first one is the original image, that is the gray image. Then binary, can you see the binary threshold? Threshold truncated, threshold to 0 to threshold inverted. Kindly try. These are the things, basic requirements you need to do before you work with your image analytics. I hope you should have completed this. Rotation, this is translation. Have you completed translation? Please do try. Yes, thank you, Suprata ma'am. Now we move on into the image thresholding. Image thresholding. First, convert the image into grayscale. That's a basic requirement for thresholding. Okay. Are you trying?
Yes, ma'am. Doing, ma'am.
Yes, please. Thank you. See, you have to know the basics of what are the analytics that you can do, and you can use your data sets. Okay. These are yesterday and today, whatever I'm doing till now are the basics that we should definitely need to work on with the data sets on image analytics. It's huge, but I've taken a few of it. Just one line you can write and copy and paste it. and change only these values and this variables here. And this for loop is used to plot the graphs. Okay. Even with Opencv itself, you can have a 1-week course because it's huge. A SkyKit image. I'm taking what are the basic packages so that according to your availability, you'll be able to use it in the future. By this, from April, at my company, I'm providing internships for students. Okay, for students especially. You can visit ciarf.co.in. If the students, they come in group, they get discounts. Okay. There, here, this is a summer internship on machine learning. It's for students, okay? So every Monday, Wednesday, Friday, 5:30 to 7:30, right from April, they'll be on to the live workshop like this for 20 hours. And then for the next 10 hours, they'll be developing a live project onto the internship. So here we have not worked on the data analysis, data visualization. Therein, they'll be learning about it. Okay, and the performance and how to take a benchmark data sets. And also in my company, we also train people on research. Okay, if you've got a research problem and if you want to address it, we train you on technologies, okay, and you will be developing codes on your own. This is for students, okay, and they at the end of it, they'll be getting a certificate, okay, they'll be getting a certificate from my company. With my company is a Section 8 company. We have registered under Ministry of Corporate Affairs, Government of India. And also the data science and the machine learning courses also we provide, deep learning, big data analytics using Hadoop, and also on software testing, cyber forensics. Okay. If you are interested or anybody is interested, you can share these details to them. Last time we completed this image analytics workshop. Okay, coming on to our session. Have you all completed thresholding? So any doubts you can ask me. At the end of the session, we've got a simple quiz to play. It's a live quiz to play. Okay, today's session, we started with Opencv, displaying an image, reading an image, writing an image, changing the color spaces, then resizing the image, then thresholding, that is what you're doing now, image rotation and image translation, 8 functionalities, okay, of using Opencv. Once you've done, we'll be able to move on to the next. Kindly respond, please. Any doubts, put onto the chat also. Yes. Can we move? Are you all trying it out? Done?
Last
Okay,
line.
okay, no problem. So there's lots and lots of things to work in healthcare and analytics. I had asked for some ideas while others are typing, and some of you share some ideas that you have that you can do. Remember, yesterday I asked you. Okay. One of you have responded. Thank you, Nitya ma'am. You're able to understand how it works, the different types of thresholding for the image that you have taken. Okay, most of you have done. Thank you for responding. Okay, so now I told you, right, you would have taken an image, okay, and we are going to use a package called Canny Edge, okay, to find the edge of an image that is used for new diseases. Okay, edges or points in an image where image brightens, changes sharply, or it has discontinuities. Okay, so discontinuities in deep, in surface, in materials, or any variations in scenes, you'll be able to do some edge detection. Okay, these are very useful features of an image that you for classification for disease is present or disease is not present. Okay, even in deep learning models, edge features extract information the presence of an object. That is what I shared you an image of Y1, which has an MRI of a brain that carries a tumor. Okay, edges are different from contours, so you should be very careful. What is edges or what is contours? Okay, edges are different from contours and they are not related. Okay, so edges detection are used for image segmentation and for image sharpening. Okay, make this point very clear in mind. Edge detection, where do we use? It is used for segmenting image and also image sharpening. Okay, then what is contour detection? You can ask a question. Determines the shape of a closed object. Okay, to check continuous points having the same color intensity, where edges are carried out by detecting the changes in color intensity, but contour having same color intensity. Okay, see, and also edges detection is carried out for the whole object, but contour detection is only for objects in their image. So there is a difference between edge detection and contour detection. Okay, in edge detection, it detects changes in color intensity, but in contour detection, it should be of same color intensity. The second is the most important difference is that in edge detection, it is a whole image. Most of the researchers also get confused. Okay, it is for the whole image, but in contour detection, it is only for objects present in the image. Okay, so this is what about the canny edge. Okay, this is a algorithm called a canny edge. Okay, so using this, can you see I'm reading an image and using this canny, somebody's mic is on. Okay, canny, I'm resizing the image and I'm showing it. And after whatever the edges it is detected, it is showing. Now we'll go into data. So I've loaded my Y1 image into the Google Drive. I'm showing it. Okay, this is the image. Okay, can you see? And I'm going to use Canny edge detection. Can you see for the whole image, it has been detected. Can you find? Okay, let's try this and then we'll go in for contour. Load the image. I'm loading it in image 11. I'm showing that image and then using Canny edge. Before going into that, I can show you about what are the process that is done in Canny edge detection. Okay, so Canny edge detection, carries out for the whole image. But contour, it's only for objects present in an image. Okay, so this is the concept of Canny edge. In Python, they've done all the coding. Just you need to import the packages. Okay, cv.canny. Okay, it's a popular edge detection algorithm. So Canny edge is, that is what you can see, the whole image's edges you can find. Okay, so first it does the noise detection. Okay, step by step it is using a Gaussian filter to reduce the noise. Then it finds the intensity gradient of the image. Okay, so using the smoothing is done by Sober kernel. Okay, and then the vertical detection. Okay, the next step it works on is called your non-maximum suppression. Then the final is hysteresis thresholding. The thresholding that is done is your hysteresis thresholding. So this is how the Canny edge detection works. Okay, any image that you give into. Now I've shared Y1 image with you. Kindly load the Y1 image. It's very easy. See, we are just using one function here, cv2.canny. But see, 5 operations are being done at the back. Noise removal, it's just thresholding, and on maximum suppression, everything is done. And then we find the edges of, from here you can find where the tumor has been infected. All right. So this is for the brain tumor edge detection. Load the image. Load the image and then perform the Canny edge. It's very simple. So using some for loops also, you can run algorithms and find data with tumor and without tumor. Okay. Others, are you trying it? Yeah, I got the response from Nitya ma'am. Okay. Can I move on? Yes or no? Are able to understand? We have done 8 computations, 9 walks using Opencv today. Whether you're able to understand? Yes. If you're not able to understand, no. Can I have the response on the chat, please? Quick.
Yes, ma'am. Yes, ma'am.
Okay, okay. Thank you.
Yes, ma'am. Ma'am, I'm getting error in the canny, ma'am.
Where are you getting the error, ma'am?
Excuse me, ma'am. I'm Abhirami, ma'am. Yeah,
And
the
then
CV2 dot.
Canny.
Yes,
Have
ma'am. CV2 dot canny, no, ma'am. I'm getting error on that place, ma'am, particularly.
Have you imported the image? Have you
Yes,
displayed the
ma'am.
image? You're
Yes,
able to
ma'am.
display the image?
Yeah, it is giving like CV2 has no attribute canny.
C is capital.
Oh, okay, okay, okay. Yes.
Okay.
Thank you, ma'am. Sorry.
You got it? Okay. So this is about the edge detection. Now we move on to your contour detection. Okay. The same only. I'm loading the same image. Okay. Now I'm converting my converting to RGB image, and then I'm converting into the grayscale. So the image is of the grayscale here. Now I'm doing a binary thresholding image. Okay, binary thresholding image underscore comma binary one CV2, the gray one, the variables, and I'm showing it. Okay, we have seen different thresholding. I'm using binary inverted thresholding. Then for finding contours, I'm finding using the function called cv2.find contours. For edge detection, I use canny. Here I'm finding contours. I'm giving the binary threshold and the tree at this is the format for the threshold functions. And I'm drawing all contours. What are the contours of intensity, color intensity? And I could see it. Herein, you can see it is not taking the entire image, only the object present in the image, where depending upon the color intensity. Able to find out? All right. So this is the function in Opencv. Find contour, Opencv. Okay. So contours, I told no, or explain as simple curves having the same color intensity. There in edge detection, it is the entire image. Okay. Image, grayscale, thresholding, finding the contours. Okay, these are the steps. Loading the image, converting to grayscale, making the thresholding, and finding the contours. Okay. So there are different contour approximation techniques also. Okay. So we'll take this image. You should have already loaded the image. Yes. Loaded the image, converting into grayscale. First convert and then plot, and then we'll go into thresholding, and then we go into finding the contours. Have you all loaded the image and then converted into the grayscale, the same image, that y1.jpg. So be very clear regarding the edge detection and contour detection. Once you've done till these 3 lines, say done onto the chat so that I'll move it up. All right. We'll convert it to grayscale. Hopefully you should have completed converting the image to grayscale. You've done it before also. This is the code for creating a binary threshold of that image. So you can see here where the intense color is, there is where your contours are detected. You want me to push a little below above? Somebody's mic is on. Are you all working on? Kindly respond, please.
Yes, ma'am. Yes, ma'am. We are working, ma'am.
Thank you. Thank you. There are a lot of algorithms available. After the session, I'll show you some demonstration. You'll be able to understand. Yeah, done. Yes, thank you, Priya ma'am. Now we'll go on to binary thresholding and finding the contour. So first step, we have to load the image, convert it to grayscale for finding contours. Okay. And then you have to create a binary thresholding of the image. So it's of same color intensity. Okay, the same color intensity only it works. Okay, but in edge detection, it's for the entire image. Contour detection is only for images having the patterns having same color intensity. After this, after you write this, I will show you the demonstration of 2 algorithms called Watershed Segmentation algorithm and how to detect faces. And the third demonstration I'll show you on of how to detect objects doing image segmentation using mask or CNN. Those are huge programs. We don't have time, but I'll show you a demonstration of it. Okay. So how to first, there's a difference between edge detection and contour detection. Edge detection carries out for the entire image, but contour detection only for objects present in an image having the same color intensity. So most of them you get confused, contours and edge. It is not the same. And because the researchers you work on with that, right? Detecting objects. Ma'am, here working. Yes, Felicia ma'am. For DCM images, For 3D image and image segmentation, you have a different header files to work on with DICOM image, right? You will use you need to load with your DICOM image reader, and then using that, you'll be able to compute the image segmentation. You have a DICOM reader in Python. As this is the first level of the workshop, I would like to balance for those who are new, those who knew something. Using Python, you can do. If even we help, we guide PhD scholars, not in developing algorithm, but giving them the technological training, and each of the scholars, they develop the algorithm on their own.
Ma'am, this is Abhirami.
Yes, ma'am.
Can you scroll the screen
Yes.
little bit upward, ma'am, not downwards? Okay. Okay, ma'am. Okay, ma'am. Thank you, ma'am.
If you need to learn about 3D, we can have a separate session. I could teach you, because we conduct a lot of courses and also customized courses for one-to-one, especially for research scholars. According to your requirements, you can get yourself trained and develop so algorithms for your own problem definition. You will be developing it. I'll give the training, and the researchers will develop. And when you get errors, will be there. I'll be there to help you to debug it. Okay. So I'll share my contact details. You can get. I've already shared my YouTube channel. You will get all my details onto my YouTube channel. Have you all got it? Got your contours? We have got next 15 minutes more. I'll show you the demonstration of the other three. If you could see on my channel, you'll be getting some ideas. Working with Python, and then disease analysis and prediction model using deep learning tools. Mostly it will be on different domains. Okay. Have you got it? Can we go on to the demonstration phase? We got your contours. This is another image. Here the color intensity is white, right? So you get the perfect contour. Can you see? Finding contours. But always your healthcare image will not be like this. Always your healthcare images will not be like this. Thank you, Nitya ma'am. Abhirami ma'am, got it?
Yes, ma'am. Yes, ma'am.
Okay. And also, this for another image I've done. This is called as Watershed Algorithm. Okay. It's called Watershed Image Segmentation Algorithm. Okay, so today we have seen about Opencv, almost 9 to 10 functionalities in Opencv. All right. And now I'm going to show you some, as we have little time, and I'll show you some demonstrations. Okay. And also I said, do you remember from my slide? Okay, edge detection content. Then we'll move on to the face detection. Okay, the face detection. How to detect face? Okay, there are different things you can detect: your eyes, your nose, or objects. For face detection, we use this called hair cascades. It's a machine learning based where it's trained with set of inputs. The different phases are being trained. Okay, so there are pre-trained classifiers. Opencv has pre-trained classifiers for face, for eyes, for smiles. Okay, we need to download the trained classifiers. Here and I've downloaded I'm just going to detect the face, so the frontal face. Okay, understand the frontal face using this is the package that you need to download. Hair cascade frontal face default.xml. So I have to load that cascade. I have to load the image, then convert the image into grayscale, and for detecting the faces and drawing the triangles around. Okay, so I'll show you the demonstration of it. Okay, this is I'm running it in Jupyter. I'm importing NumPy CV2. All right, for face cascade, I am taking like frontal face. For eye, if you want to detect, you can use eye.xml. Okay, I am using an image called test3. This is the image, test3. This is an image. Okay, this is my father, my mother, my husband, myself, and my 2 kids. Okay, and here you can see it's near the sea, and my dad's shirt color is getting combined with that. So you will find the difference when now I'm converting it to the grayscale. So this is the grayscale of that image. So 1, 2, 3, 4, 5, 6. Okay, but see, number of faces found is only 5. Okay, I'm drawing the rectangles around. Can you see? For my mother, for myself, my husband, for my kids, there is no triangle for my dad. The reason behind, he wears the shirt of the same color, it's blended. Okay, so you need to even more optimize your algorithm. So this is how you can detect your face recognition. Okay, your face, your eyes, your nose, everything could be detected. So using this hair cascade frontal face. For eyes, it's different. For ears, it's different. For smiles, okay. This is about your face detection using Opencv. And we were working with this, right? This is the same image. Okay, I'm reading that image, which is of a grayscale. Okay, converting it. And then I'm using to remove the salt, pepper noise. Yesterday we have done the median filter. I'm making the median blur. Okay, and then I'm using whatever we have learned. Okay, the CB2 color change, the Gaussian blur, and I'm blurring it. And I'm using Sobel filter to remove the noises. And again, I'm thresholding that image and removing what are there in the foreground. I'm dilating that image, removing, identifying the white and the foreground and the background. Then I'm subtracting the foreground and the background. And herein I'm using the watershed algorithm. So there is an algorithm called watershed. I'm using fine contours, sure FG. Okay. Can you see only the place where there is a tumor, it has been detected. Okay. So this algorithm is also used for image segmentation. Watershed algorithm. removing the foreground, the background, the unknown region, and then you get your contour. Can you see? This is about your watershed algorithm. I've done it for this as we are not having time to complete. Okay, so this is, you can also try it, okay, about the watershed algorithm. Okay, I'm using the water coins, okay, converting into grayscale, performing the threshold. These are the basics we have learned thoroughly. Thus, you have to put it onto it, okay, and I've done the thresholding. This is the grayscale of the image, and for the morphology, okay, thresholding. So then I'm getting what are the diffusion dilations, what are the show of background, what are the show of foreground, and I'm subtracting it. What are the unknown areas? Then I'm labeling it and using the watershed algorithm, using image on the markers, I get the segmented image. The same thing also, the same thing only I worked with the image. Can you see? Yes or no? Can you see here?
Yes, ma'am.
Yeah,
Yes.
exactly. There is a part of tumor here and also little here. Can you see here also, little here? Yes, the tumor spread here and there. And same thing you could have seen in our contour also. When you have taken the contour, we have not done the segmentation, but even in the contour, what happened? Not this, not this, not this. The brain. Can you see here? Little? Yes?
Yes, ma'am.
Yeah. Same thing. Here also it is done. All right. So a lot of things you can do in image. You've just started with the basics. All right. So about watershed, about phase recognition, we have seen. Any doubts till now? Let me see onto the chat. Okay. So this is about, and also in here you can change your runtimes from CPU to TPU. Okay. And here now I will show you a demonstration about how to do image segmentation. Okay, I'm going to take a direct image. It's using mask or CNN convolution neural network. I'm using TensorFlow. Okay, and I'm making an ID for if it is a by person, it is one, bicycle two, different IDs in an image. Okay, and then I'm loading it from an image. It's a street image from directly from website. I'm loading it on. It's running. All right. Okay, and I'll show you that it will display the image. So this is the image I want to segment. You can see people and persons with cycle. Some of the IDs like Caesars, teddy bear, mouses, laptops, cake, feathered on it. I've mapped it on. I'm making a TensorFlow session to work on with and have a pre-trained, as we have used hair cascade. I'm using a pre-trained model. And then here I'm going to work with the segmentation. Image segmentation itself we can have a workshop with. Okay, and I'm going to visualize the detected results. I'm giving maximum boxes to draw as 50. Let's see, we'll get, before we get this on, and Let me see whether it is loaded. Can you see onto my screen? See, it is segmenting
ma'am.
them. Yeah, this is how you can do your image segmentation. It's just a demonstration. So I showed you about the mask or CNN. The lot of things are there in segmentation. Let's see in the future we'll be able to see about it. Okay, today we have seen in depth about Opencv. So now we are going to play a simple quiz. Look onto the chat. So any queries, you can feel free to call me or WhatsApp me onto my number and share my number details at the end of the session. Let's start playing the quiz now. Have you all got the link? Oh my God. No, no. Don't use that link. When you click the link, what do you get?
It told to
Use,
sign in using the account, ma'am.
no, don't use that link. Use the second link that I've given. Sorry.
Oh,
Use the
okay, ma'am.
second link. Use the second link that I've given. So you give your name and then join in, please. Yeah, one of them have joined. Yeah, two have joined. Yes, please. Kindly join. One, like 20 seconds. Okay, others, are you joining? Okay, three of them are joined. Others, please do join. It's very, very simple. Yeah, can we start? Yes. We're going to start. Only four have joined. Just click the link, give your name, and you can join. The first question: Sobel filter was used in SkyKit image for what purpose? Image segmentation or finding edges in an image, or for image blurring? Yesterday, you remember we saw about SkyKit image. Just simple 3-4 questions. Everyone asserted. Yes, most of you have given the right answer. Let's see who has given the right answer and who's the fastest. Abhirami ma'am, Jose ma'am, I don't know who's Dragonite. They have not renamed it. Okay, Abhirami ma'am, you're the winner for the first round and you're the fastest. Congratulations. Let's see the second question. Opencv stands for, today we were seeing about Opencv, open source computer visibility, open source classical vision, open source computer vision. What's the right answer? What does Opencv stands for? All of you have given the right answer and see who's the fastest. First round it was Abhi ma'am and she was the fastest. And here, those who are given Dragonite also no problem, just join in. And this time Jose ma'am is the fastest and Abhi ma'am is still the first. The final question, I don't know what was the question I asked. Let's see. Hair cascade based object detection is used for content detection, edge detection, face recognition. Hair cascade. I showed you the demonstration also. Yes, it is used for face recognition. You remember I showed you the XML for face recognition. Hair cascade for face. Okay, hair cascade. Yeah, Nitya ma'am, you've given the right answer. And the winner is Nitya ma'am. We'll go to the next question. What are the concepts you learned yesterday and today in this image analytics workshop? You can just type in. Each of you can type in up to 10. Today itself we have learned more than 8 and yesterday different packages. Just type in and keep entering it. Yes, please. You're typing it. Type and then submit. That's it. You need not give all the 10. Whatever you know, you can just type it and then submit. Are you able to do it? I'm not, yeah. Cleaning, data mining, validation with diagnosis, segmentation, nice. Face detection, content detection. Only 2, what about the other 3? Quick, fast. Validation, image manipulation, image segmentation. We have seen about image rotation. Then we saw about image translation, image thresholding, augmented, grayscale. Beautiful. So all of you have submitted. Nobody has given about the packages, the SkyKit package, NumPy, SkyPy. Yes, packages. Thank you. The data sets. Thank you. The face. Lot of data sets of available. Image filtering. Okay. We'll move on to the next question. The final question. Okay. This doesn't carry a leaderboard. Okay. What's the feedback about the online hands-on image analytics for healthcare using Python workshop by the resource person, myself, Dr. D. Doreen Robin? How did you, what was your experiences? Yes, did you enjoy? Did you learn something new? Anything more to improvise? Many packages, learned new terms. Awesome. Thank you. What about others? What did you learn? Each of you can give up till 10 words. For some, it should have been new. For some, you have little experience. Some of you will be more experienced. All right. So it was good to have you all the past 2 days. Thank you. Nice answer, more examples, clear explanation. Need repeated training. Excellent. We'll go for the next. You can contact me if you wish to have one more on a detailed session. Some of you were asking about 3D. Okay. Excellent communication. Like to learn more, learn new terms, new experience with video record. Thank you. Thank you all for the splendid timing that they've given to share with you all. So the winner of this game, last two questions are not taken for the points, only the first three questions. And the winner in today's quiz is Nitya Ananda Vasagam, ma'am. Congratulations, ma'am. Congratulations. So I will share my contact details, my number, my mail ID, and my company's ID. You can make a note of it. All right. You can make a note, and you need for more training or whatever sessions on deep learning or machine learning or data, I'll be able to do it by the grace of God. So please do contact me. Learn even more better, teach even more better, do your research as well. But once again, I would like to thank the entire management of SRM, Ramapuram campus, the principal, the HOD ma'am, Marani ma'am, the organizers, Belina ma'am, for having invited me for the two days workshop of image analytics for healthcare using Python. Thank you all. God bless. Over to the organizers.
Uh, Thank you, ma'am. That was informative session, ma'am, for the 2 days. Thank you so much, ma'am.
Welcome.
Okay. With that, we come to the end of the session. I now request Mrs. Priya, Assistant Professor, Department of Computer Science, SRM IST Ramapuram, to deliver the vote of thanks.
I'm honored and delighted to take this opportunity to thank the gathering on this special day. I must mention our deep sense of appreciation to Dr. Doran Robin ma'am for sharing about the Python packages in image processing. I also extend my sincere thanks to the management for encouraging us to conduct this 2 days online international workshop. And I also wish to express my gratitude to Principal SNH. I render my special thanks to our Vice Principal Academic, Vice Principal Admin, and our beloved HOD for their consistent support. Finally, I would like to thank the participants shown very much interested in this workshop for their kind support. Thank you all.
Thank you, ma'am.
Thank
Participants, the feedback link is posted in the chat box. Okay. Just complete the feedback. Okay. Those who all complete the registration process and all the formalities for the FDP session, your e-certificate will be you will be receive your e-certificate within 2 days. Okay. So I request all the participants to fill the feedback form. The feedback form is available in the chat box. Yes.
Then next one is top is equal to top minus one. Automatically and increases value. So this will be iterated once again and again. So until the
Participants, you
top.
can wait for 2 minutes.
Okay, so if you become the zero automatically the graph will become. So this is the implementation of mock operation.
Okay. So with that, we can come to the end. We can move on to the national anthem. Okay. Participants, complete your feedback form. It will be available in the chat box. I just post 1 second. Okay. So you need to complete the feedback for both the session, both the days, day 1 and day 2. Again, I post the feedback link in the chat box. Complete the feedback form. Okay. Your e-certificate will be, you will receive your e-certificate within 2 days. Okay. Thank you, Doreen, ma'am. Thank you, ma'am. It is a very informative session, ma'am. Thank you, ma'am.
Thank you, sir.
Thank you,
And
ma'am.
bye-bye.
Thank you. Bye, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you. Welcome.
Ma'am,
Thank you, ma'am.
Hari there. Shall I ask you one question, ma'am? I'm having some doubt.
Yes, please.
You said that you can use DICOMer for reading 3D images. So my doubt is, so we need to slice
For
the
DICOM, no, for DICOM image, you can use DICOM reader. For
Yeah.
3D images, you should use the relevant packages from Python.
Yeah, okay. So what my doubt is, or we need to slice the images as
You can do image slicing.
slicing. Is that necessary, or we can take or read the 3D itself and work on that, which is better, ma'am?
Both
Which
ways
one
it
is
is
better?
possible. Both ways it is possible. You
So
can take
reading and
the
slicing.
image, you can read the 3D image and do computation onto the 3D image. If you want to slice, you can do the image slicing of the 3D image and you can extract the necessary features according to your problem definition and you can work on with that.
Okay. Finally, I have to reconstruct it.
Yes.
Yeah. Thank you, ma'am. It's very
Welcome.
informative.
Thank you so much. You can contact me for further details. Any other questions with the participants? Start working on with that. If you have not any queries, contact me to my number on WhatsApp or mail me. All right. Okay. So can I leave now? Belina ma'am?
Ma'am, good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
Good afternoon, ma'am.
Yes, ma'am.
Yeah.
Ma'am, your session was very nice, ma'am. It was very, we gained a new experience, ma'am.
Thank you. Thank you, ma'am. Thank you. We'll see furthermore in the future collaborations. Okay. Thank you all. God bless. Bye-bye.
Thank you, ma'am. Thank you, ma'am.
Once you fill the feedback, you can leave the session. Thank you. Thank you all the participants.
Those who have completed can leave the session, participants.